Hey, welcome back to ISOMath. Today we're going to talk about finding the shortcut derivative rules using the product rule and the quotient rule. So let's get right at it. Okay, the product and quotient rules. That simply means first we talk about the product rule. That means when we have a function times another function. And that simply means we can have something like x cubed times e to the 3x as an example of a function times a function. That's written as x cubed e to the 3x. So here we have two different functions. And obviously the quotient rule is when we have a function divided by a function. So an example of that would be something like x cubed divided by e to the 3x. So we have a function divided by a function. So let's get right at it and take a look at an example. First we're going to talk about the product rule. Here's your rule for the product rule. When you have a function times a function, define its derivative. It's going to be f prime of g plus f g prime. What does that mean? Well, let's take an example right here. Here we have clearly identify a function times a function. We have x squared, which is a function, times another function, which is e to the x. So we're going to identify one of the functions, f, as x squared. And then we're going to identify the other function as g. So g is equivalent to e to the x. And what we need to do is we need to find the derivative of both of these guys individually. So f prime, the derivative of x squared, as we know, using the power rule, is nothing more than 2x. Yes, there's an invisible dx there, but we're going to leave it as 2x. And derivative of e to the x, we know from previous examples, we can do it the long way, using that's nothing more than an exponential rule, which is a to the x, which is going to be ln of e times e to the x, but we know that ln of e is simply 1, so that derivative is nothing more than e to the x, because this piece right here equals 1. So we have our four components now, and now we have to piece it together using the product rule. It tells us that the derivative of two functions, when we multiply the derivative of two functions, when we multiply them together, is going to be f prime of g plus f g prime. And now that I identify my four pieces, I know f prime is 2x, my g is e to the x, and my f piece here is over there is x squared, and my g prime is right there, which is another e to the x. So this ends up being the result of the derivative. And yes, I can factor out an x and I can factor out an e to the x, but essentially these are my components. After simplification, we'll combine terms. We got 2x e to the x squared, or I'm sorry, 2x times e to the x plus an x squared e to the x. And likewise, like I said, we can factor out an x and an e to the x. So in simplest terms, we can have this being nothing more than x e to the x times a 2 plus an x. And that would be the answer that you would find in the back of your book. But essentially, this is how we get to that final answer. Alright, let's try another one. Let's change up colors here. Let's go with a little red. So let's take a look at this guy. Here I'm trying to find the derivative of here, and here what you want to identify is, remember, always hop on that airplane, and you want to zoom or take off, look down at the function from, like, say 10,000 feet in the air and see the overall picture. The overall picture is I have a function here times another function there, and that's what you want to be able to identify. You want to identify your components, your two pieces. So in this case, I'm going to have my f piece is going to be this first piece right there, which is that quantity 3x squared plus a 5x. And then my g piece, or my other function that I'm multiplying by, is going to be nothing more than e to the x. And knowing this from the product rule, this is what I have these two. To find the derivative of these two pieces, I want to keep it up that f prime g plus the f times g prime. So I need to find my derivative of this component, which is my f component, using the power and the constant multiplier rule. This is going to be nothing more than 6x plus 5, and g prime, from what we did, yes, the long way is ln of e to the x, but we know that's simply going to be e to the x. Now piece it together, I'm going to have f prime of g plus f g prime. I'm going to piece it all together. So the derivative of this guy is going to be the 6x plus 5. Keep your parentheses, keep everything nice and tight. G is e to the x. Then I got my f piece, which is 3x squared plus 5x times e to the x. And once again, I can factor out an e to the x and some other components, all that good stuff, but essentially that is going to be my answer. Not in simplest terms, but that is my derivative. So that's how you use the product rule. Let's take a look at how we're going to use the quotient rule. The quotient rule is when you have a quotient, you have a function divided by a function. What you're going to use in this case is going to be f prime times g minus f g prime all over g squared. So we're going to take a look at this guy. We're going to try to find the derivative of this piece. Now obviously your f is always your function on top. So in this case my f function has to be 5x squared. While my g piece, my bottom function, will always be what's on the bottom, in this case x cubed plus 1. And just like before, I got to find the derivative of f prime, which using my power and constant multiplier rule gives me 10x. And g prime, finding that comes out to being just straight up power rule, 3x squared, then obviously plus a 0. So those are my components, and now I got to piece it together using that f prime of g minus f g prime all over g squared. So my f prime is 10x, and my g obviously is my x cubed plus 1 minus, and my f is 5x squared, times my g prime, which is 3x squared, all over my g squared, which is going to be this piece right here, which is quantity x cubed plus 1, the quantity squared. Make sure you square that entire term, that entire quantity down below. And that will be your derivative. Yes, I can distribute my 10x through in simplified terms and maybe pull some stuff out, but ultimately I'll leave that for you. This is the derivative, and then the answer in your back of your book would be simplified out if you need to pull out the common terms. Alright, let's try another one. Here I got x over x squared plus 1. So top piece has to be x, always has, the top function has to be f. My bottom function is x squared plus 1. F prime in this case is going to be 1, and g prime is going to be 2x, and obviously plus 0. Piece it together using my nice little anagram there. So f prime is going to be 1 times my g, which is x squared plus quantity plus 1, minus my f, which is x, times my g prime, which is 2x, all over my g squared. So that's going to be the quantity x squared plus 1 squared. Make sure you keep that as a quantity. And likewise, I'm sure I'll be able to pull something out and simplify out, but that is the first step, and I'll leave the simplification for you guys. So, hope that has helped, and remember, check back to ISOmath with all your math needs, and we'll see you soon.